Data scientist tools. Data engineering is a field that focuses on designing, building, and maintaining the systems and infrastructure required to collect, store, process, and analyze large volumes of data. Data engineers utilize a wide range of tools and technologies to ensure efficient and reliable data processing. In this explanation, I will provide an overview of some popular data engineering tools within a 1,000-word limit. 1. Apache Hadoop. Hadoop is an open-source framework that provides distributed storage and processing capabilities for big data. It consists of the Hadoop Distributed File System, HDFS, for scalable storage and the MapReduce programming model for parallel data processing. 2. Apache Spark. Spark is an in-memory distributed computing framework that offers high-performance data processing capabilities. It supports various programming languages, such as Scala, Python, and Java, and provides libraries for batch processing, real-time streaming, machine learning, and graph processing. 3. Apache Kafka. Kafka is a distributed streaming platform that enables the collection and processing of real-time data streams. It provides high-throughput, fault-tolerant, and scalable messaging capabilities, making it suitable for building data pipelines, event-driven architectures, and streaming applications. 4. Apache Airflow. Airflow is an open-source platform for programmatically orchestrating and scheduling complex data workflows. It allows data engineers to define and manage workflows as code, making it easier to monitor, schedule, and execute tasks across different systems. 5. Apache NiFi. NiFi is a data integration and data flow management tool that facilitates the automation of data movement between various systems. It provides a visual interface for designing data pipelines and supports real-time data ingestion, transformation, routing, and enrichment. 6. Apache Scoop. Scoop is a tool designed to transfer data between Hadoop and relational databases. It enables the import of data from databases into Hadoop and the export of data from Hadoop to databases, allowing seamless integration between traditional data stores and big data ecosystems. 7. Apache Flume. Flume is a distributed, reliable, and scalable service for collecting, aggregating, and moving large amounts of log data from various sources into Hadoop. It supports a wide range of data sources and provides customizable data ingestion pipelines. 8. Apache Beam. Beam is a unified programming model and set of APIs for building batch and streaming data processing pipelines. It provides a portable framework that can be executed on various processing engines, such as Apache Spark, Apache Flink, and Google Cloud Dataflow. 9. Elasticsearch. Elasticsearch is a distributed search and analytics engine that is commonly used for full-text search, log analysis, and real-time data exploration. It offers powerful indexing and querying capabilities, as well as integration with other data engineering and visualization tools. 10. Apache Cassandra. Cassandra is a highly scalable and distributed NoSQL database designed to handle large amounts of data across multiple commodity servers. It provides high availability, fault tolerance, and tunable consistency, making it suitable for applications that require high write and read throughput. 11. Apache Storm. Storm is a distributed real-time computation system for processing continuous streams of data. It provides fault-tolerant stream processing capabilities and supports various use cases such as real-time analytics, event processing, and online machine learning. 12. Apache Flink. Flink is an open-source stream processing framework that supports both batch and stream processing paradigms. It provides low-latency, high-throughput data processing and supports event time processing, state management, and fault tolerance. 13. SQL-based databases. Relational databases such as PostgreSQL, MySQL, and Oracle are widely used for structured data storage and querying. They offer mature transactional support, data integrity, and support for complex queries and aggregations. 14. NoSQL databases. NoSQL databases like MongoDB, Couchbase, and Redis are suitable for storing and processing unstructured or semi-structured data. They provide flexible schemas, horizontal scalability, and high-performance data access for use cases such as document storage, key-value stores, and caching. 15. Data warehousing tools. Data warehousing tools like Amazon Redshift, Google BigQuery, and Snowflake are designed for storing and analyzing large volumes of structured data. They offer scalable, columnar storage, and provide advanced querying capabilities for business intelligence and analytics purposes. 16. ETL, extract, transform, load, tools. ETL tools like Informatica PowerCenter, Talent, and Apache NiFi facilitate the extraction, transformation, and loading of data from various sources into target systems. They provide graphical interfaces for designing data integration workflows, data mapping, and data quality management. 17. Workflow orchestration tools. Workflow orchestration tools such as Luigi, Azkaban, and Oozie enable the scheduling, coordination, and execution of data workflows and dependencies. They provide visual interfaces or DSLs, domain-specific languages, to define complex data pipelines and manage dependencies between tasks. 18. Data quality tools. Data quality tools like Talent Data Quality, Trifacta, and Informatica Data Quality help identify, cleanse, and standardize data to ensure its accuracy, completeness, and consistency. They provide features such as data profiling, data cleansing, and data validation. 19. Data integration tools. Data integration tools such as Pentaho Data Integration, IBM InfoSphere DataStage, and Oracle Data Integrator allow for the integration of data from various sources into a unified view. They provide capabilities for data mapping, transformation, and synchronization across different data formats and systems. 20. Data governance tools. Data governance tools such as Calibra, Alation, and Informatica Axon help organizations manage and govern their data assets. They provide capabilities for data cataloging, data lineage, data stewardship, and compliance with data regulations. 21. Version control systems. Version control systems like Git, SVN, and Mercurial are essential for managing and tracking changes to code, scripts, and configuration files in data engineering projects. They enable collaboration, code review, and the ability to revert to previous versions of the codebase. 22. Containerization and orchestration tools. Containerization tools like Docker and container orchestration platforms like Kubernetes provide efficient and scalable deployment of data engineering applications and services. They allow for the packaging of applications into containers and the management of containerized environments. 23. Workflow monitoring and alerting tools. Tools like Grafana, Prometheus, and ElkStack, Elasticsearch, Logstash, Kibana, offer monitoring, logging, and alerting capabilities for data engineering workflows. They enable the collection and visualization of metrics, logs, and system health information to monitor and troubleshoot data pipelines. 24. Cloud services. Cloud platforms such as Amazon Web Services, AWS, Microsoft Azure, and Google Cloud Platform, GCP, offer a wide range of services for data engineering, including storage, compute, data processing, and analytics. They provide scalable infrastructure and managed services for building and operating data-intensive applications. It's important to note that this list represents a subset of the vast array of tools available in the data engineering ecosystem. The selection of tools depends on the specific requirements of the project, the nature of the data, the team's expertise, and the overall architecture and technology stack chosen. Thanks for watching.